Hi guys, this lesson we are going to talk about solving quadratic and linear systems. So earlier in the year we did solving systems of linear equations, and what that was is we were looking for the point that was a solution to both equations, that worked for both equations. When you were graphing it, it was the point where the two lines intersected. So now what we're going to be doing is you are going to be taking a quadratic or a curve and a line and seeing, well, what point or points will they intersect at? And that will be your solution to your system, okay? So again, right here, we are looking for where the curve and the line intersect. And that point or points must satisfy both or all of the equations that are being dealt with, okay? How many solutions do you think a quadratic linear system can have? Well, there's a couple different answers to that. So you could have, let's say we had a curve that goes like this, and we have a line that goes like this. You could have two solutions because they cross at 2 points. You could also have a curve that goes like this. And then let's say this line just comes and hits at 1 point right here and then keeps going. That would mean there would only be one solution. And then you could also have a curve and let's say a line down here, and they don't even cross. So that means that there would be no solutions. Okay, so we're going to talk about two different ways how to solve these, by graphing and solving algebraically. So the first example I am going to solve by graphing. Okay, first thing I'm going to do is graph my quadratic. All right, now I am just going to type this into my calculator because I think it's a little bit easier to get my points. Okay, and then I can get a table of values. Just looking at this, I know it's going to cross the y-axis at -1 because you know this is your y-intercept. And then I also am going to look for my axis of symmetry. That axis of symmetry, remember, is x equals -b over 2a. So I'm going to think -6 over 2 times 1. So my axis of symmetry is going to be, this is -1, is going to be x equals +3. So right here is going to be that axis of symmetry. X equals +3. This is going to be that axis of symmetry for my quadratic. So not only do I know that this is the point of my quadratic, that's 3 units to the left of my axis of symmetry, I could also plot a point right here. Okay, then I can go into my table and because I know that the axis of symmetry, the x coordinate is going to be 3, I am just going to take that point, 3, 8, plot it, and then I'm going to plot a couple points to the right and to the left of it. So 3 is 8, 2 is 7, so that means I know that there's going to be a point over here also. And 1 is +4, so since I'm putting a point 2 units to the left of the axis of symmetry, I can put a point 2 units to the right of the axis of symmetry. And then I'm going to connect my points. Making a nice curve. Okay, and I can label this f of x. Okay, now I'm going to graph g of x, which is x plus 3. I know that the y-intercept is +3, so I can start by making a point there. And then I know my slope, my m, is 1 over 1, so I can make a couple points going up like this, okay? I also did put it in the table, and I could have gotten some points from that table right there. All right, so I'm going to draw a line in connecting my points and put an arrows on it and label this g of x. Okay, so I can see that my graph intersects at this point and this point. So I could say the solution to this system, it has two solutions, 1, 4 and 4, 7. So those would be my two solutions. The other method that we could use to solve this would be to solve algebraically. Okay, so let's go through and I'll show you how to solve this algebraically. So this is saying I want to know for which values of x is f of x equal to g of x. And actually, if I read my question carefully, it's really only asking for the values of x. So here I see that they cross at 1, 4 and 4, 7. But the actual values of x that we're dealing with are 1, 4. Okay, so algebraically, we want to know when f of x equals g of x. So what you're going to do is you're going to set your equations equal to each other. So I'm going to say negative x squared plus 6x minus 1 equals x plus 3. So now I have to go through and solve and get x by itself. So the first thing I want to do is I want to get all of my variables to one side. So I'm going to subtract x, and I'm also going to subtract 3. I'm going to move everything to the left side. So I now have negative x squared plus 5x minus 4 equals 0. Now this is going back to the last unit where we're going to go through and we could factor this. We could use the quadratic formula. We could solve by completing the square. Or you're going to use one of those methods to get x by itself. So I am first going to divide everything by -1 because I want to get rid of that negative out in front of my quadratic. So now I have x squared minus 5x plus 4 equals 0. Now, when I look at this, I think the easiest thing to do is to factor it. And I see that I could factor this to x minus 1 and x minus 4. All right, so then I could solve this. X minus 1 equals 0, so that means x is going to be 1. And if I have x minus 4 equals 0, that means x could be positive 4. So these are the two possible x values where these functions would equal each other. Now, this is just asking for the x value, but if it asked for the 2 points, you then have to take what you had found for x and plug it into one of the equations and solve for y. So in this case, I would use g of x. It's an easier equation to use to solve for y. So let's say if x is 1, what is, so we have g of x equals x plus 3. If our x value is 1, what would be the y value that goes with it? 4. So you have the point 1, 4 is one of your solutions. Okay? Do the same thing for your second point. So if my x value is 4, I'm going to plug it in. 4 plus 3. That means 4, 7 would be another solution. And those would be the two solutions to this system. Now remember, both points have to satisfy both equations. So you should go back and check your work, okay? So if I have f of x equals negative x squared plus 6x minus 1, f of 1 let's see, negative 1 plus 6 is 5. 5 minus 1 is 4, so you get the 0.14. That worked. Okay, check the second point to see if that works also. So we get negative 16. Oops, I should have put 4 in there. So we get negative 16 plus 24, or plus 24. Minus 1 is 7. So you have, oops. So you have f of 4 equals 7. So the 0.47, it worked for that equation. Okay. So now we know that those 2 points worked for both of our equations. Okay, let's take a look at another example. So this one says to solve graphically and solve algebraically. What I am going to do, though, is the number 2, I'm going to solve algebraically. And number 3, I'll go through and I'll solve that one graphically, just to save a little bit of time. All right, so number 2, solve algebraically. So remember the methods that we had learned were substitution, elimination, graphically. This one, I am going to use substitution because I have y by itself. I know this equals y. So I'm going to take that and I'm going to substitute it in for y into my other equation. So I'm going to think 2 times x squared minus 4x plus 5 minus x equals 6. All right, so now I have to go through and simplify this. So the first thing I'm going to do is distribute. I get 2x squared minus 8x plus 10 minus x equals 6. Okay, I am going to get everything to one side. So I'm going to subtract 6 from both sides. And I am going to combine my like terms. So I'm going to have 2x squared minus 9x plus 4 equals 0. Okay, so now at this point, we have a couple of options. We could go through and solve this by factoring. We could go through and we could solve this by using the quadratic formula. Factoring, I think, is going to be a little bit difficult. Quadratic formula, why don't we do it that way? All right. So I'm going to think x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So I'm going to plug in negative b, so this is going to end up being positive 9, plus or minus negative 9 squared minus 4 times 2 times 4 all over 2 times 2. So we get 9 plus or minus 81. 81 minus 32. Let's see. What do we get? 16 times 2, 81 minus 32. We get 49. So plus or minus the square root of 49 all over 4. All right, and the square root of 49 is 7. So I have two possible answers. I have x equals 9 plus 7 divided by 4. So that's 16. 16 divided by 4 is 4. Or x equals 9 minus 7, over 4. So 9 minus 7 is 2. 2 divided by 4 is 0.5. All right, so now that I have my two values for x, what I'm going to do is plug them into one of the equations to find the y. Okay. I'm going to use the top equation. I'm going to come up here. So y equals x squared minus 4x plus 5. I'm going to plug in, let's start with 4. 4 squared minus 4 times 4 plus 5. So 4 squared is 16. 16 minus 8 is 8. 8 plus 5 is 13. Is that right? Oh no, I'm sorry. This is 4 squared is 16. 16 minus 16 is 0 plus 5. So y is 5. So that means that when x is 4, y is 5. That's one solution. Okay, now we're going to do the same thing and plug in 0.5 into your x. So I'm going to think 0.5 squared minus 4 times 0.5 plus 5 equals. All right, when I plug that in, I get 0.25 minus 2 plus 5. So I end up with 3.25. So the second solution is 0.5, 3.25. So 1 and 2. Okay, so now we could check by plugging these into the other equation. Also a good way to check, because we solved this algebraically, you could put these equations into your calculator and make sure that you get the same intersection point. So I'm going to say x squared minus 4x plus 5. And then the second equation, I have to get, let's see, we have 2y minus x equals 6. I have to get y by itself. So I'm going to add x to both sides. 2y equals x plus 6 divided by 2. So y equals 1/2 x plus 3. So if I put that into my calculator, 1/2 x plus 3, I can graph it. And then remember, you can hit second, trace, scroll down to intersect. I'm on the first curve, second curve, enter, and I get that point, 0.5, 3.25. So I know this one was correct. And I'm going to check the second point of intersection. So again, go down to intersect. I'm going to scroll over, enter. It's on the red line, enter, and I get the 0.45. So then again, I know this point is also correct. Okay. All right, let's look at the next one. So the next one, I am going to go through this one and just solve it by graphing. Okay. All right, so first thing, when I go to graph this, I know that it's going to go through 0, 0. That's going to be where it crosses the y-axis. X equals negative 6 over 2 times 2. So x equals negative 6 over 4. X equals, 1.5. X equals 1.5. Okay. All right, so I'm going to put in my calculator 2x squared plus 6x. And then the second equation, this one right here, I have to get y by itself. So I'm going to add y to both sides. I have negative 2x equals 8 plus y, subtract to 8. So y equals negative 2x plus 8. All right. All right. So to find that vertex, if x is negative, if x is negative 1.5, I can substitute that in to find my y. 2 times negative 1.5 squared plus 6 times negative 1.5. And what do we get for that? We end up with negative 4.5. So I know negative 1.5, negative 4.5 is my vertex point. So negative 1.5, negative 4.5, right about here is that vertex point. Okay. I also know that this is my axis of symmetry. Okay. So if I have this point, that's 1.5 units to the left of my axis of symmetry. I can also plot a point right here. That's 1.5 units to the right. All right, I'm going to look at my table of values to get maybe 1 or 2 more points. All right, so I have 0, 0. We got that one. 1, 8. So 1, 8 is going to be right here. Did I type something in wrong? I feel like I did. Y equals 2x squared plus 6x. Oh, I know what I did. This is going to be at negative 1.5, negative 4.5, right here. So I can have that other point right here. Okay, 1, 8, and then I'll have a point right over here. All right, so I can draw in that nice curve. Draw in that nice curve. And then I can graph my line. Also, I know that this is going to cross the y-axis at positive 8, and then the slope is negative 2 to the right 1, negative 2 to the right 1. This should be negative 8. Okay, let's see. Negative 8. Let's do a different color. Negative 8, down 2 to the right 1, down 2 to the right 1. And it is going to be a nice straight line. Just like that. All right, put some arrows on it. There we go. Okay, so now we can see that it is going to cross. Oh, my line's off just a little bit. There we go. It is going to cross at one point. Oops, why does it keep moving on me? It's going to cross at one point. Oh, come on. Let me draw that line one more time. There we go. Okay, and you can see that it's going to cross at one point right here. All right, and it looks like that is the point -2, -4. And I'm going to check my work. If I look at my graph, whoops, if I look at my graph, that looks just like what I've drawn in, and then I can check, go down to intersect, and it gives us our answer of -2, -4. Perfect. Okay. All right, so the next one I am going to go through and solve. I'm going to do this one algebraically. And then we can check our work with the graph. All right, so again, I'm going to use substitution because I have y by itself here. So I'm going to take my -4 and I'm going to plug it in. So I'm going to have 2y, whoops, nope. I am going to have 2 times -4 equals x squared minus 12. All right, so I get -8 equals x squared minus 12. So when I'm trying to get x by itself, I am going to bring everything to the one side. So I'm going to add 8 to both sides. I get 0 equals x squared minus 4. All right. So now I'm going to think, all right, I don't have a b term. So I could solve this by square rooting. I am going to add 4 to both sides. I guess I could have done this up here, but I didn't notice. So I get 4 equals x squared. I'm then going to take the square root of both sides. So positive and -2 equals x. Now remember, that's just my x value. So now I have to go back and I have to find, well, what would the y value be when x is 2? So if I plug in, I'm going to use that top equation again. If I have positive 2 squared, I get 2 equals 4 minus 12 is -8. Divided by 2, I get y equals -4. And think about this, if I were to plug in -2, I'm going to get the same answer. So my solution is going to be 2, -4, and -2, -4. And this makes sense because if we look at it, this equation right here is y equals -4. And that is going to be a horizontal line going across like this. And then our curve is going to come down. Here it's going to come down like this. And so it's crossing at these 2 points. Okay? And again, we can check this in our calculator. I can do 1/2 x squared minus 6 and y equals -4. Graph it, and then you can see where they intersect each other. -2, -4. And then we could do the same thing on the other side. Okay? Okay, last question for these notes. This is going to be going back and forth. And actually, I think I'm going to skip this question for today. I'm just going to leave you to solve just the basic equations, and we will do a separate day dealing with word problems. So I hope this video was helpful. Again, if you have any questions, feel free to email me and I will get back to you as soon as possible. Enjoy the rest of your day.